Good morning. Welcome to today's session. In today's session, we will be dealing with electrodynamics, and I hope that your teacher have done it already in class, that you can use this session as brush up and making sure that you've got all the loose ends together. If not, I'm going to go through everything that is important in this topic, and I'm quite sure that even then you will be happy at the end of the session. When you think of electrodynamics, then it's very important that you should think marks. This is a section where I really feel that you guys can do well. So please pay careful attention and make sure that you know what to do in this section. Right, so if we look, we're going to start off, and I always like, when I start, to have a look at what is in our examination guideline. I like to first stand still at that area so that you also have a good idea of what will be expected from you in the exam. So let us start off with electrodynamics, and we will then first look at the exam guidelines. Right. On this presentation of mine, you will see the whole section here deals with electrodynamics and what will be expected of you. Let's look at it. Under electrodynamics, we are looking at electrical machines. And we are looking at two machines, the generator and the motor. Right, so what is expected of us? First of all, we have to state the energy conversions in generators. We must have a good understanding of the principle of electromagnetic induction and explain how a generator works. You guys will see, I will later also summarize this part for you guys. Right, then we will explain the functions of the components of an AC and a DC generator. We will state the examples of uses of AC and DC generators, and we will state the energy conversions in motors. Right, so that is, in short, some of the things that we will expect. In the motor also, we will expect you also to explain how the motor works. We will look at the functions of the components in a motor, and we will also state examples of uses of motors. So if we look at this, the first part here deals with generators, examples of use, functions of the components, principles on which it works, and also the energy conversion. And then we go down to motors, the very same thing, energy conversions, how it works, function of the components, examples. All right. Then the next section, after we've dealt with machines, will be to look at alternating current, because you will see that alternating current do form part of this section where we specifically look at the alternating current generator. So that is, we will then go into more in-depth into alternating current. With alternating current, we will look at the advantages of alternating current over direct current. We will look at graphs, where alternating current plays a role, and what we can deduct from those graphs, and how we can work with those graphs, how can we use it for information. Right, then we will look at root mean square, the term RMS. It stands for root mean square, and we will work with that. And then you will see on your data sheet, you will find a couple of formulas where we will do some calculation type questions. We will be able to calculate the current root mean square if I know what's a maximum current, or vice versa. If I know what's the root mean square, I can calculate the maximum current for alternating current, and the same for potential difference. So you will see that these two formulas is actually very simple formulas. It's a simple one-step, one value substitution, divide by the square root of 2 will give me the answer. Very easy to use. Then we are looking at problems using power. Power, the brightness, that is linked to power, where we will have a couple of formulas, which very simple substitutions also, whereby we can then use these formulas for different ones, depending on what is given to you, depending on what you have to calculate. We will look at problems where we will work with power. So in short, that is what is expected of you in the in the exam guidelines. All right, so let us first look at the following. If I then summarize what we've just gone through, you will have to make a little table for yourselves, and in that table you will say, what is the components of an electric motor? What is the components of a generator? What is the principle on which an electric motor is working? What is the principle in what a generator is working? Energy conversion for both, uses for both, and you need to be able to explain the working. This table of mine summarizes this part, where I've looked at what is in the exam guideline. So a good idea for you would be to be able, after this presentation, to tick that box, to be able to say, all right, I understand and I know the components, the principles, the energy conversions, and so on. All right, so at the end, I would like to be able to say, yes, we can tick all of these boxes. Then we've gone through the content of this first section which deals with machines. All right, so let us look at the electrodynamics, and you will see here at the corner I've posted a little picture just to give us a reminder of what is important in terms of the content. So that very same table, I just put it there on the side, just to see, am I addressing what is really necessary to be addressed? Now, when we look at electrodynamics, the first is that what we will see is, and you've done that in grade 11, is that electricity and magnetism are linked. They have an influence on one another, and there's an electric magnetic force that is a result of that link. So if you think back of grade 11, you will remember the following. The following is that whenever I have an electric conveying conductor where current is flowing through, and I place it in a magnetic field, the moment when there's a change in the magnetic flux, then there's a force experience. Or the other way around, you can say the moment when I have an electric conductor and there's a change in the flux in the magnetic field, there can be an induced current in that conductor. So that is where we found, we already saw last year that there's a link between magnetism and electricity. All right, so if we go then into specifics, there's in electrodynamics only two possible, or the two that we will be looking at, is the energy conversion. Now I can either have a situation where electrical energy will be converted to mechanical energy, or the other way around. Mechanical energy can be converted to electrical energy. Now let me give you an example, and what I'm going to do is I'm going to just shortly go out here, and I want to show you an example of a generator and a motor. Yes, so if we have a look here, then you will see here I've got a magnet, and this magnet, let us just take away all of these just for simple purposes. There I've got a magnet, there I've got the external circuit where there is electricity provided. So you can see electrical energy is provided here, and as a result of that, with the components given here, I have mechanical energy. This part is now rotating here, and it's because it's experiencing a force. Now the force that it is experiencing, I can show that in the diagram. So I can pause it shortly. Because of the current flowing through it, and this section being in this magnetic field, let me show you the magnetic field, it is now experiencing force. So you can see, I can also indicate the current direction, where the current flows conventionally from the positive through this section, and it goes through, and I have a completed circuit there. I'll come back later to the components that we have here. I just wanted to show the energy conversion in this apparatus, which is the electric motor. Is electrical energy is converted to mechanical.